I've been reviewing the Guangdong Self-Study Exam syllabus for switching and routing technology. The emphasis on VLANs and trunking seems heavy. Why do you think that is?
VLANs are the backbone of network segmentation in real-world deployments. Trunking ensures efficient traffic flow between switches, especially in multi-VLAN environments. Without these, networks become chaotic and unmanageable.
That makes sense. But I'm curious, how does link aggregation play into this? The syllabus lists it as a core technology, but it feels like it's often overlooked in practice.
Link aggregation isn't just about bandwidth, it's about redundancy and load balancing. Imagine a campus network with thousands of users. A single link failure could cripple the system. Aggregation mitigates that risk.
I see your point. Speaking of redundancy, the syllabus also highlights MSTP and VRRP. How do these protocols interact in a real-world campus network?
MSTP prevents loops in switched networks, while VRRP ensures router failover. Together, they create a resilient infrastructure. For example, if a primary router fails, VRRP kicks in, and MSTP ensures no loops form during the transition.
The exam also stresses DHCP and NAT. Both seem basic, but the syllabus treats them as critical. Why do you think that is?
DHCP automates IP management, which is vital in large networks. NAT, on the other hand, conserves public IPs and adds a layer of security. Both are essential for scalability and security in modern networks.
I noticed OSPF is included, but not other routing protocols like BGP. Do you think the exam is focusing on enterprise networks rather than ISP-level routing?
Exactly. OSPF is ideal for enterprise environments. It's efficient, scalable, and supports hierarchical designs. BGP is more for ISPs, which might be beyond the scope of this exam.
The syllabus mentions wireless configuration with AC and AP. How does this tie into the rest of the switching and routing curriculum?
Wireless is no longer optional. It's integrated into campus networks. ACs manage APs centrally, and proper configuration ensures seamless roaming and security. It's all about unifying wired and wireless infrastructure.
The exam structure allocates 30% to application-level questions. Do you think hands-on projects like building a 3-layer campus network are the key to mastering this?
Absolutely. Theory only gets you so far. Projects force you to apply VLANs, OSPF, MSTP, and more in a cohesive design. That's where real learning happens.
I'm glad the syllabus emphasizes practical projects. It's easy to get lost in theory, but real-world application is what matters.
Agreed. And with tools like Huawei's ENSP simulator, students can practice without risking real infrastructure. It's a game changer for hands-on learning.
The syllabus mentions PPP and CHAP under WAN protocols. How do these fit into modern enterprise networks, especially with the rise of MPLS and SD-WAN?
PPP and CHAP might seem outdated, but they're still foundational for understanding authentication and encapsulation. Even with MPLS or SD-WAN, the principles of secure link establishment remain the same.
That's a good point. The exam also includes firewall configuration. Do you think it's more about ACLs or full-fledged firewall policies?
For this exam, I'd focus on ACLs, how to apply them on routers and switches to filter traffic. Full-fledged firewalls are more advanced, but ACLs are the building blocks.
I've noticed the syllabus emphasizes the 3-layer campus network model. How would you design one using only the technologies listed, like VLANs, OSPF, and MSTP?
Start with the core layer using OSPF for dynamic routing. Distribute VLANs across the access layer and use MSTP to prevent loops. Link aggregation ensures redundancy between layers.
That's a solid approach, but how would you integrate wireless? The syllabus mentions AC and AP configuration. Where do they fit in?
Wireless APs connect to the access layer switches, while the AC manages them centrally. It's about treating wireless as an extension of the wired network, not a separate entity.
The exam's 30% application focus makes me think of troubleshooting. How would you diagnose a VLAN misconfiguration in a real-world scenario?
First, check the trunk ports. Are all VLANs allowed? Then verify the access ports. If traffic isn't flowing, use Show VLAN and Show MAC address table to trace the issue.
What about OSPF troubleshooting? The syllabus highlights it, but it's easy to get lost in neighbor states and LSAs.
Start with Show IP OSPF Neighbor. If neighbors aren't forming, check hello timers, area IDs, and authentication. LSAs, use Show IP OSPF Database to verify propagation.
The exam's closed-book format means memorizing commands is key. Do you think flashcards for CLI commands would be more effective than lab practice?
Flashcards help, but labs are irreplaceable. Muscle memory for commands like show running config or debug IP OSPF comes from hands-on practice, not rote memorization.
I like your focus on practicality. For someone like Jiwei Li, who prefers using multiple laptops for parallel tasks, how would you recommend setting up a lab environment?
Perfect for this scenario. Use one laptop for the core layer, another for access, and a third for wireless. Ubuntu or macOS can run GNS3 or ENSP for virtual devices, mirroring real-world segmentation.
That's a clever setup. It aligns with the exam's emphasis on hands-on projects and avoids the complexity of managing everything in a single environment.
Exactly. Physical separation simplifies troubleshooting and mirrors how real networks are managed. Different teams handle different layers.
Ziwei, you mentioned using multiple laptops for parallel tasks. How would you simulate a 3-layer campus network across 3 devices for hands-on practice?
I dedicate one laptop to the core layer with OSPF, another to the distribution layer with VLANs and MSTP, and the third to the access layer with APs and ACs. Use ENSP on each to virtualize the devices.
That's efficient. But how do you handle inter-device communication? Would you use physical cables or virtual connections?
For simplicity, I'd use a small physical switch to connect the laptops. It mimics real-world cabling and avoids the complexity of virtual networking software.
The exam includes firewall basics. How would you integrate a firewall into this setup without overcomplicating it?
Add a 4th device or use one laptop to run a virtual firewall like pfSense. Apply ACLs between layers to simulate security policies, just enough to cover the exam scope.
You've mentioned Ubuntu and macOS for parallel tasks. Do you find one OS better suited for networking labs than the other?
Ubuntu is more flexible for networking tools like Wireshark and GNS3, but macOS handles virtualization smoothly. For this exam, either works. Pick what you're comfortable with.
The syllabus stresses DHCP and NAT. How would you demonstrate NAT traversal in a multi-device lab?
Configure one laptop as the Internet with a public IP range, another as the router doing NAT, and the third as a client requesting an internal IP. Use ping and traceroute to verify connectivity.
That's a practical way to visualize NAT. What about troubleshooting? The exam has a 30% application focus. How do you practice that?
Break things intentionally. Disable a trunk port, misconfigure OSPF, or block a VLAN. Then use CLI commands to diagnose and fix it. The exam tests problem solving, not just setup.
I like that approach. For someone with your setup, would you recommend documenting each step on a separate laptop to avoid confusion?
Absolutely. Use one laptop solely for documentation, screenshots, CLI outputs, and notes. It keeps the process organized and mirrors real-world network documentation practices.
The exam's closed-book format means memorizing key concepts. How do you balance memorization with hands-on practice?
Focus on understanding why things work, like why OSPF uses areas, or how MSTP prevents loops. Hands-on practice reinforces memory better than flashcards ever could.
That's a great mindset. Finally, how would you simulate a wireless network in this setup? The syllabus includes AC and AP configuration.
Use one laptop as the AC and connect a physical AP to it. Configure SSIDs and security settings, then test connectivity from another laptop acting as a client. It's simple but effective.
This aligns perfectly with your preference for physical separation. It's refreshing to see how your multi-laptop approach simplifies complex networking concepts.
Exactly. Physical separation reduces cognitive load, letting you focus on mastering the technology, not the tools.
Jiwei, you've emphasized physical separation for networking labs. How would you simulate a redundant VRRP setup across your laptops?
I'd use 2 laptops as VRRP routers, One is master, one is backup, connected to a third laptop acting as the core switch. Failover testing is just a matter of unplugging the master.
That's a clean way to demonstrate redundancy. What about integrating PPP and CHAP? The syllabus includes them, but they feel outdated.
Use a serial cable between two laptops to simulate a WAN link. Configure PPP with CHAP authentication. It's a hands-on way to understand legacy protocols still used in some enterprise setups.
You mentioned Ubuntu for networking tools. How would you use it to monitor traffic between your laptops during these labs?
Install Wireshark on Ubuntu, then mirror traffic from the switch laptop to the monitoring laptop. It's a real-time way to see how VLANs, OSPF, or NAT behave under the hood.
The exam includes MSTP for loop prevention. How would you intentionally create and then troubleshoot a loop in your setup?
Connect two switches, laptops, with redundant links. Disable MSTP and watch the broadcast storm. Then enable MSTP and verify loop resolution with Show Spanning Tree.
That's a powerful way to internalize MSTP's role. For DHCP, how would you simulate a rogue server attack and mitigate it?
Run a fake DHCP server on one laptop, then use IP helper address on the switch laptop to forward requests only to the legitimate server. It's a simple but effective security demo.
Your approach aligns with the exam's 40% comprehension focus. How do you ensure you're not just memorizing, but truly understanding these mechanisms?
By breaking and fixing things repeatedly. For example, misconfigure OSPF areas, then debug with Show IP OSPF interface. The exam tests comprehension, not rote recall.
The syllabus mentions wireless AC and AP setup. How would you extend your multi-laptop lab to include wireless without adding complexity?
Use one laptop as the AC, connect a physical AP to it, and configure SSIDs. Another laptop acts as a wireless client. Simple, but covers all exam requirements.
You've avoided virtualization software. Do you think this physical approach limits scalability, or is it sufficient for the exam scope?
For this exam, physical separation is scalable enough. Virtualization adds layers of abstraction that aren't necessary when the goal is mastering core technologies.
The exam's 30% application focus includes firewall basics. How would you demonstrate ACL's blocking traffic between VLANs?
Configure ACLs on the distribution layer laptop to deny traffic between two VLANs. Use ping tests from the access layer to verify the rules. Immediate feedback.
Your method of using physical movement, e.g., unplugging cables, to simulate failures is brilliant. Does this help with exam time management too?
Absolutely. Physical actions are faster than typing commands, so you spend less time on setup and more on analysis, critical for the exam's 150-minute limit.
Finally, how do you document your labs? The exam emphasizes practical projects, and documentation is key.
I dedicate one laptop to documentation, screenshots of CLI outputs, network diagrams, and step-by-step notes. It's a habit that mirrors real-world network administration.